Okay, hello everyone. My name is Omkar Joshi. I'm course instructor for computational thinking, and I will be conducting today's session, which is open session for week 9, and the session is being live streamed. So whoever has a doubt, please you can raise your hand and we can have a discussion about it. Yes, anyone? Any doubts? No doubts. Am I audible in the first place?
Yes, sir, you are audible.
Okay. So no doubts, huh?
Sir, I wanted to ask, like, what is a clique, sir? CLIQUE.
Yeah, but it's a click. Okay, fine. It's one of the most common questions. So, okay, hold on. Let me whiteboard. Is this whiteboard visible?
Yes, sir.
Okay, so I don't have any digital pen, so my writing might be shaky, but we'll try to make it up for it. Okay, so I have this node A, node B, this is node C, and to consider this is D, okay? Better. Okay, and I'll have couple of edges among these. So this is a edge, and this is another edge. Okay, so this is a graph. It's an undirected graph, right? Hello.
Yes, and
Yes,
that.
sir.
Yeah. So who asked this doubt? By the way, may I know your name? I missed it.
Yashwant.
Yashwant. Okay, so Yashwant is an undirected graph with 4 vertices and 4 edges, right? Maybe
Yes,
let's add one more. Let's say 5 edges. Okay. And now listen to this. What is a clique? I mean, the formal definition and all this is fine, but I will tell you very in a basic manner what clique is. Clique is a subgraph. It can be entire graph or a subgraph where each node is connected with every other node with direct edge. Okay, let me repeat. It can be a graph or a subgraph where every node is connected with every other node with an direct edge. Are you understanding this part?
yes, sir.
So now this graph, if you observe, there are 4 vertices, 4 nodes, but only A, B, and D. These 3 are connected with direct edges, right? A is connected to B and D. B is connected to A and D is also connected to AB. So all 3 vertices are connected with each other with direct edges. Whereas C doesn't fulfill this property because C is connected to B and D, but C is not directly connected to A. The direct connection is important. Of course, C is connected to A via B or D, but there is no direct edge between A and C. And because of that, C is not part of the clique. A, B, D forms the clique. Because in that clique, there are 3 nodes, and all 3 nodes are connected with each other with direct edges. That is clique. Okay.
Okay, sir.
And let's say if I add one more edge like this. Now what is clique? I mean, what is the updated clique in this particular graph?
ABCD.
ABCD,
ABC,
right? So the
ADC.
entire graph forms a clique.
Sir, if we remove the diagonal, then it is not a clique.
No, it is a
Cool.
clique, but
No,
not entire graph is not a clique. A subgraph is a clique.
Okay, suppose the DB, the diagonal between D and B, if we remove it, then it's not a clique.
Then it's not a clique, correct.
That means clique has a 3 node and all nodes are connected to each other.
Yes, I mean, hypothetically, you can say AB is a clique or BC is a clique, AD is a clique or CD is a clique. You can say that. but it doesn't make any sense, right? Because every edge will form a clique if you consider like that.
Okay.
Right. So usually we do not count those as a cliques. We count clique when number of nodes are 3 and above. Because 2 nodes can form a clique if there is an edge. And that doesn't give much of information, right? It just tells us that yes, there is an edge between those 2 nodes, which anyway we can get from list of edges.
Okay, sir.
Right. When I say, let's say A, B, C, D is a clique, I don't have to tell you explicitly that how many edges are there. There are 4 nodes, and I say those 4 nodes form a clique. With simple formula, you can tell me how many edges are there. You can easily form that graph, right? If let's say I remove everything, okay, just blank. There is a blank thing, blank page is there, and I'm asking you, and I'm just telling you that there is a clique with a clique of 4 nodes, A, B, C, D. Can you draw it for me without any additional information? I'm just telling you a clique of A, B, C, D.
We just first draw a 4 node and also connect it to with each
Connect
other.
every node with each other, right?
Each other, yes.
Yes, but if I tell you, okay, AB is a clique.
AB is a clique.
That doesn't give much of information, right? I mean, I just say, I can say AB is a clique or AB is a edge. It doesn't, it's still same, right?
Yes.
Yeah, so that's why I'm saying, whenever we talk about cliques, we expect that the size should be at least 3. Otherwise, it's just a pair of nodes connected with a edge, right?
Okay, right, sir. Here, one concept, sir, yesterday told, like a jump. A to B is a jump, something like. Can you explain it?
Hop.
Sir, in the previous click question, I have a query. The last solve with instructor, there was a question that to choose the wrong one. There is an option. There was a 2 click, and there was a 1 click with 2 edges and another click with 3 edges. So there they count. There are 2 clicks. If this kind of questions come, we found some clicks with 2 edges, we will count or we will not going to count it.
Okay, then do not count clicks with two nodes. 2 edges.
But in that question, that was true.
Yeah. So that's what I'm saying. I'm not saying it's incorrect. It is a click.
Okay.
It satisfies the given definition, right? What I said, click is a graph or a subgraph where each node is connected with every other node with an direct edge. Correct. So this property or this definition is satisfied by that.
Yes.
Correct.
Yes.
So that's why I said I'm not. That's why I was saying I mean it's not like we will not consider it as a click. Definitely we will consider it as a click. But the point is, it doesn't make any sense in considering or processing it as a click. It doesn't have any application as such. If the click is of size 2, it is still a click, right? By definition, it's a click. But application wise or usefulness wise, it doesn't provide any additional.
That much usually meaning. There is no meaning.
Yes, correct, exactly.
But in the question format, if we found that like this kind of click, so we mentioned there are click.
Yes, you can. You should. In fact, whenever we talk about clicks in general, right? I mean, we have introduced this in CT as a just as an introductory level. Later on, you will study a lot of applications of clicks and usefulness of this. So when you do that, actually we focus. We do not just focus on clicks. We focus on something called as max click.
Max.
Okay, max click as in the click with highest number of nodes in it.
Okay.
So, I mean, for example, currently you have this graph on your screen, right? It's still visible. Yeah. So if even though if you consider a click with 2 nodes, as in AB is a click, BC is a click, and so on, then there are 5 edges. That means there are 5 clicks by default, right? By default. Yes. On top of that, there is one more click which is ABD.
Yes.
But when we, with respect to application perspective, when we talk about this graph and click, we consider only one click, which is ABD, because that has maximum nodes in it.
Yes.
So with that, all these smaller clicks, right? So I mean, every edge form a click, right? So those
by the
clicks
definition.
yeah, by definition. So those clicks are always ignored because they doesn't provide any new information as such. Right. So that's why I said max click is more important than just click. But I mean, there is a big algorithm in order with respect to max click and so on, that anyway you will study later on. But we just wanted to introduce you to this new term called click, which you have understood by, I assume you guys have understood, and that's more than enough at this point of time.
Okay.
Okay. Yeah. And
Thank
that's
you,
why
sir.
if you will not see any pseudocode based on click directly. I mean, yeah, there
Yes.
might be some question, but
there are some question to find the clicks and all.
Yeah. I mean, that's a
table.
understanding level. I mean, in a solve with us instructor and all, that's fine. But in general, I'm saying, I mean, what I'm trying to say is, there are standard algorithms based on clicks. Okay, very popular algorithms are out there, which we are not teaching you or studying at the part of this course. Such as one, as I mentioned, like max click. Finding a max click or the properties of max click has a very big importance with respect to algorithms and graph theory. So that's something will come in later stage of the PDSA course you might have heard about, right?
Okay. So, yes, I heard about that.
Yeah,
so click, the word is same for all cycling things, all these things.
Yeah. See, click is a standard word. It's not something.
No, in math, this is we used to call complete graph. That's why I'm using it.
Yeah. See, complete graph is different and click is different. Maybe see, complete graph is with respect to entire graph, right? Click can be a subgraph also. Not necessary that it should be an entire graph, right? As I said, ABD is a graph, but with respect to mathematical property, you cannot say ABD is a complete graph.
No.
Right. So that difference is there. Because see, this click is a computer science concept, not a mathematical concept. So you will not see, you will not even hear this word click in math with respect to mathematics. But with respect to computer science, it has many applications, which you will study as I mentioned.
Okay. Now I get it.
Yeah, sure.
Thank you, sir.
Sure, thanks. Yeah, somebody in between was asked about, so if click is closed, I think previous person was talking about hop, right?
Yes, hop.
Okay. Once again, who was that? Sorry, I really.
Even that was my question too.
Okay, Yashwant, right?
Yes, sir.
Yeah. Okay. Yeah, Yashwant. So the what I was saying is the word is hop. Okay, HOP, hop. Okay. And with simple terms, I mean, right now, let me explain you with respect to this graph, and then I will give you a day-to-day example. For example, right now, I want to go from A to C. Is there any direct way?
No.
Yashwant?
No, sir.
No, right? There is no direct way to go from A to C. So there are two possibilities. Either you go from A to B and then B to C, or you go from A to D and then from D to C. Correct? So in either of these paths, you require one intermediate node. So the another term I am throwing at you is intermediate node, and that intermediate node is also in other terms it is also referred as hop. So you hop, so you move from A to B. So B is your hop, it's your hopping node, and from there you went to C. So your actual destination is different, but in between you have to get on to something else in order to reach to your destination.
Oh, I think, sir, this term has come from island hopping.
Yes, correct.
Yeah, because this is the same concept, like same intermediate. Concept.
Yes, intermediate node.
Hmm.
So, for example, Yashwant, where are you from?
It's a Bangalore.
Where?
Bengaluru.
right? So, okay, I mean, unfortunately or fortunately, there is a direct train, flight, buses. So many options are there from Bengaluru to Chennai. But let's say you are going from Bengaluru to maybe some remote parts of Tamil Nadu. Okay, it's nearby. Agree, but there is no direct airport. Let's say at that particular place. So what you will do? Maybe you will take a flight from Bengaluru airport to Chennai airport. And from Chennai airport, or you will go to that whichever place you want to visit. So you will visit Chennai first, even though that was not your destination. So that becomes your hop. Right? So that's the place
Yes,
where
sir.
you change your mode of transport, or maybe you change your train or change your bus or whatever. Right? So that intermediate station, intermediate node is referred as hop. Okay, it's that simple. I mean, it may sound some rocket science, but that's not the case.
I think, sir, the word jump is we should not use here because that jump word is confusing.
Okay, I mean, I don't
Because-
know
Sir,
who used that jump word and where, but
yeah, because sir, if we use jump word, then it will be like two jumps somebody is taking, like from A to B
Yeah.
and B to C. That's
Correct.
what I think we should not use jump word. The hop is the correct word.
hop is the correct word.
Yes.
But even with respect to hop or jump, right?
Yeah,
When I say
literally
there
in
is
English
a,
meaning it is
yeah.
jump, but we should not
Yeah.
use jump here.
Right. So I mean, there is a
Confusing
difference.
otherwise,
I will tell you. When I say you are traveling from A to C via B, let's say, okay. So B is your hop. So if I say there is one hop in between, that means there are two edges involved. Or with respect to train data set, if there is one hop, that means there are two trains involved. So if there is one hop, that means there are two jumps. So if you are considering with respect to jumps, then hop is not just jump. So jumps is equal to hop plus one. That is how it works. So if there is one hop, then there are two jumps. One jump from A to B and the second jump from B to C. So it's always plus one. So you should not misunderstand between hop and jump. These two are different terms. So that's why I said if you're traveling from A to C, you first took a train from A to B. You are supposed to change the train at B and take a second train from B to C. So that what does that mean? If there is one hop involved, that means you are traveling on two trains. Similarly, let's say
That's when hop is the intermediate node.
Yes, it's an increment. It's a intermediate node. For example,
Sir,
A to D. A to
sir,
D,
hop,
there is no. Yeah.
Hop more than one hop is possible.
Yes, possible. That's what I was going to explain now. Consider this graph now. You want to travel from A to A to D.
Yeah.
Okay, A to D you want to travel, but there is no direct edge, so you have to go to A to B. So B becomes your first hop. Then you took a second train from B to C, so that's your second hop. And then you took a train from C to D, train, flight, whatever, bus, or whatever you want. So I mean, you just transition from one node to another node. So if you consider there are two hops, B and C, but actual number of edges you do traverse or number of jumps which you took is 2 plus 1. So it's always hops plus 1. Number of transitions which are happening. Okay. Is it clear?
Yes.
And
Sir, here
not
hop.
necessary one hop or two hop. There can be n number of hops. So we have that
Depends on the
algorithm.
graph.
There is, I think, a algorithm which Professor Madhavan explained with respect to n hop. I'm not sure it's in week 9 or 10, but if it's not in 9, then it will come in week 10. I think it's in week 9 only. 5, 6, 7, 8. No, not 9. Sorry,
It's 10.
It's in week 10. It's in week 10. Week 10. Week 10. So if you have not watched, it's fine. You will study that.
Not
It's part of, it's part of week 10. So in week 10, you will study one algorithm called, I mean, not algorithm, one pseudocode called nhop something, nhop root or something he calls it. So it's there. So yeah. Okay, all right. So it's possible to have multiple hops.
Yes, sir.
I have a
Yeah.
doubt in this concept, sir.
Yeah,
Uh,
Ganesh, go ahead.
Question is related to activity question 9.3, question number 4, sir. This concept, but on that question, I can't understand what they try to tell. They are given the feedback, but
Okay.
but
Fine. Yeah, I saw. I think you posted in the chat also 9.3 question 4, right? Some Tarika,
Yes.
I think, posted, not you.
Sir,
but-
me posted. I
Yeah,
posted.
but same, right?
Yes,
You
sir,
also
same.
have same question, right, Ganesh?
Yes, sir.
Anyway, I mean, I would say if 9.3 only, we will discuss both if they are different. Okay. So, question 4, right?
yes, sir.
Okay. So the question 4 is, consider there are 15 telephone booths on an island. Is it possible to connect them with wires so that each telephone booth is connected with exactly 5 other telephone booths, right?
Yes, sir.
How many telephone booths are there total?
15.
15. And out of those 15, exactly 5 are supposed to be connected with each other, right? I mean, every node should have 5 connections. That's what it means, right?
Yes,
Every
sir.
telephone booth should have 5 connections. Correct?
Yes, sir. Correct.
Okay. So, okay. Have you read this? I mean, this is pretty much, it concludes everything. But anyway, what it says, in every node has 5 connections. Correct? Then that means
Yes.
how many total number of connections will be there?
So 15 into 5.
No, not 15 into 5, right?
Because
Yeah, if I mean if 15 into 5, that means you are counting same connection twice, no?
yes, sir. Like A to C and C to A.
So
we
15 into
divide
5, then you have to divide it by 2, no?
divided by 2.
So that is it's a fraction, right? So you
Yes.
cannot have 37.5 edges. You can have either 37 edges or 38 edges. You cannot have 37.5 edges. So that's why it's not practically possible to derive a graph or to make connections with this in this manner.
Sir, I am
Okay.
not getting, because in that it is mentioned n into n minus 1 divided by 2.
Yes.
So that formula is confusing, sir, because what is n?
So it should be
here?
then
I
as
think
per
15
that, yeah. It should be like 15 into 14 then.
No. See, okay.
Yeah.
I understand why the confusion is there. For this question, this formula is not directly related. I will tell you. Okay, forget about this formula. I will come to that formula later. I mean, immediately after this. First, have you understood why the answer is no?
Yes, sir.
Right? There are 5 telephones. I mean, see, all 15 telephones has to be are there. And every telephone is supposed to be connected with 5 other telephones. So there are definitely 15 into 5 divided by 2. This is a fraction, so it's not possible. That part, is it clear?
Yes, sir.
Okay. Now coming to this particular formula, n into n minus 1 divided by 2. So this formula is a generic formula to calculate total number of, to calculate, total number of edges in a complete graph. Okay, that means if there are 15 telephone booths and I want to connect each one of them with every other telephone booth. Okay,
That means you are telling click like that, sir.
that is click, correct. That is a complete graph or a click.
Click.
Right?
Okay.
Then this is the formula to get total number of edges. That is 15 into 14 divided by 2. Those many number of edges will be there if 15 nodes are connected with every other node. So that's the formula. But here we want to, we don't want to connect every node with every other node, right?
Yes,
So
sir.
that's the place where required a modified version of this one, which is this 15 into 5 part.
Okay, sir.
Okay.
Okay.
Why I will tell you is, see, why it is n into n minus 1? Because n is what? There are 15 nodes. And each node will be connected to how many other nodes?
14, one less
14
than
nodes,
that.
right?
Less than
14
that.
nodes. So that's why it is 15 into 14 divided by 2. But this time I want to connect 15, but not to 14, to 5 only.
Yes, sir.
So that's why it is 15 into 5 divided by 2. So that's why this, instead of
Got it, sir.
14 part, we replaced it with 5.
Okay, sir.
Okay, I mean, I understand the confusion, but this is the reason or the relation between this formula and this one. All right.
Yes, sir.
Yeah.
Clear. Thank you, sir.
Sure. Thanks. Okay. Anybody else? And guys, if now we have some 20 plus people, so if you have doubt, please raise your hand so that
Sir.
everybody will get a fair chance. Okay. Yeah, Anand, I'm taking your question, but here onwards, whoever has a doubt, please raise your hand so that everyone will get a fair chance. Or yes, Anand, tell me. Anand, sorry, not Anand, it's Anand. Yeah, Anand.
Yes, sir.
Yeah.
Sir, practice assignment 9, sir, big 9, question number 7. There are hope related questions, sir.
Okay.
In this question, maximum number of hope n-1, sir, given.
Okay.
Sir, please explain this question.
Yeah, sure. Question number
7, sir, 7.
7. Have you referred to the solution?
Yes, sir, but I can't understand.
Okay, so this question is, I think it's related to some previous question. And these are some dependent questions, right? Yeah, 5 to 8 are based on some common pseudocode. Okay, fine. So 7.1 it says the variable hops satisfies which of the following inequalities. Okay. Okay, fine. So we have to find one of the out of these, which one is right. So this is 7. Okay, so have you understood this pseudocode in the first place? Because the question is based on this. Anant?
Yes, sir. Yes, sir.
Yeah, so have you understood this pseudocode?
Yes, sir.
Can you tell me what is happening in this pseudocode?
Sir, n denotes the number of rows.
What is this S?
And sir, S serial number, sir.
S is?
Serial number.
Serial number. No, I mean S is guys came from where? I mean it's A, right? Matrix A has been computed. So what is this matrix A in the first place? I mean it's everything is interlinked, no? So if you have understood A, then you will understand this pseudocode. If you understand this pseudocode, then only you will understand that problem number 7. So you have to go, trace back and figure out whether you have understood A in the first place. So what is A? A is something which we have computed over here. So what is A? Anand?
Sir, is
And by the way, S is not serial number, okay? S is a dictionary. It has serial number as keys, but it's a dictionary.
sorry, sir. My network is so big. So I started a meeting.
Hello?
Hello. Yes,
Yeah,
sir.
Anand. Yeah, your voice was breaking. I understood your network is bad.
Network
Am I
connection is
audible?
weak, sir.
Okay, at least am I audible,
sir,
or
yes, sir.
still bad from my side also?
You are audible, sir. But I said network is so big, sir. So I can't explain this question.
Okay, fine. So I'll quickly go through it, and maybe if you lose connection in between or something, later on you can watch it on YouTube, okay? Because it will,
Okay,
it
sir.
will get recorded.
Okay.
So see, S is a dictionary. So let me start from the beginning. S is a dictionary. What it do? It's a
Yes, the
what
2 and 2 to 4 question is also mine. I'm not able to understand the code.
Yeah, fine. So anyway, I mean, during explanation, I will explain that also. So what is this S? S is a dictionary. It has serial number as keys and corresponding scores as values, right? So serial number 0 got 50 marks, serial number some maybe 1 got 80 marks, and so on. So whatever that serial number is a key, and whatever the score of that student is its value, right? That is how the dictionary is generated. Now, with that information, we are trying to compute this particular pseudocode. Okay.
Sir, I have a doubt in
Yeah.
line number 2, sir. So they are given create matrix of n comma n.
Yes.
So we are imagine that will create a matrix of n rows and n columns.
Not imagining. This create matrix is a special function which we have discussed in one of the lectures of week 9.
Yes, sir.
Yeah.
Like our professor tells
Yeah.
that matrix is related to dict of dict, I think.
Yeah, it's a nested dictionary, correct.
Yes, sir. But in Python, the dictionary is totally different concept from that matrix, I think, because we are using pandas library like that. So matrix is different from that one. So we are saying that
No, Ganesh, hold on, finish. Pandas is different, matrix is different, and all that is completely different, and it's in Python. Let's not go there. The matrix is what? It's a two-dimensional structure, right?
Yes, sir.
That's important, right? That in mathematics, matrix is a two-dimensional structure. That's all. How you implement it's up to you. Either you implement it using just
yes, sir. So
right. So in CT we have implemented
yes,
it as a dictionary of dictionaries.
Sir, I have confused in that one. So why we didn't use a list of list concept? So why we use dict of dict?
Okay, let's say if I say
random access.
Yes, exactly what Jivraj said. It gives the random access. If I say I want to access second element of second column, third row, like matrix M of 3 2. Let's say I want to access M32. Okay.
Sir, yeah,
Can
sir.
you do that using list? Ganesh,
but we can able to access. Yeah, sir. But we can able to access the list from the index value. Like if the list has 0, 1.
No, Ganesh, we cannot. That's my point. Whatever we have studied, that's why the point is Python is different. Do not misunderstand Python concepts with CT concepts. Okay.
Okay. Sir.
In CT, we do not have this privilege of accessing element using index. That is why we iterate over list using that for each loop, right? For each element in list. That is why we have first of list, last of list, init, rest. All these are there because index-wise access is not there with respect to list. That is how we have defined lists.
Okay, sir. So in our CT, we didn't
not in our
the...
CT. Actually, see, not in our CT. That is how most of the data structures or programming languages are developed. Python is an exception because list is a short form for linked list. I mean, the way you are sounding is, I believe you know, have some computer science background, right?
Yeah, sir.
With respect to linked list, you cannot directly access one random element in between, right?
Yes, sir.
And that is why the lists, whatever we are talking about, doesn't allow us to have that index-wise access, right?
Yes.
But dictionary provides that functionality. And that is why we have implemented it as dictionary of dictionaries.
Okay, sir.
Okay. Now, is it clear?
Sir. Yes, sir. Yes, sir.
And one more thing, pandas don't use pandas with respect to matrices. Okay. For matrix, we use NumPy, not pandas.
Okay, NumPy. Yeah, sir.
Yeah. Okay. So anyway, that's Python, where we can discuss that maybe next term when you come to Python. But at this point of time, this is where we are, dictionary of dictionaries. It will give us a matrix of size n by n. Right, that is what this line 2 is.
Okay. Yes, sir.
Okay, so going back to the original track.
Yes, sir. The thing is that here, SR is the difference between IJ. I has to be higher.
Okay,
I has to be greater.
There is an age from I to J if and only if I's score is strictly greater than J. Yes, I has to be greater.
Then ARC equal to 1, then in the matrix 1 will store on that place where I is greater than J, right?
Correct. So if there is a age from R to C, that means R scores greater mark than C. Or I mean, you call it IJ or RC, doesn't matter. It's just a variable. So the age will be between I mean, if when we say ARC, that means R has scored more marks than C. So there are two students, right? When we access a matrix with two numbers, as I was talking about earlier, M32. If M32 is 1, that means student number 3 has scored more marks than student 2.
Roll number 2. Then there's a
Roll.
age from 3 to 2.
Correct. Age from 3 to 2. This is a directed age.
Directed age.
It cannot be undirected, right? Because though both cannot have scored more than each other. Only one can score more than other person. So this graph is a directed graph.
Yes. But
Okay.
in that question is saying that then what is the following statement R is true? So the answer is I'm confused because it stored the highest number, but how is stored the less minimum numbers?
Okay. A row R of matrix has 3 entries that are equal to 1 and the rest are 0. Which of the following statements are the student R is true? Okay. About the student R is true. So for student R, there are 3 entries in 3 entries that are equal. Okay, a row. Okay, in a row, those 3 entries are equal, right? What does that imply?
That R is then the higher marks than others.
At least not at least exactly
3%. Only 3.
Only 3. Okay.
3 entries are higher marks.
Yeah, so that's what, right? There are exactly 3 students who have scored less than student R. I mean, what you are saying is R scored more than 3 students. The statement says there are 3 students who have scored less than R. I mean, it's same thing, right?
There are exactly 3 students who have scored less than. The 3 students already have more marks than R. I'm confused.
See. Okay. Who was that? Kajari, right?
Yes.
Yeah. Okay. So Kajari, listen to this. Forget about this option. As after reading this pseudocode, what is your understanding, or after reading this statement? There are 3 students, right? Who got lesser marks than R. That is why R row has 3 ones in it. Okay. Let's consider like this.
Sir, I think if we make a matrix, then she will understand clearly, because
Yeah,
this is what I have done with the data.
Okay.
And I was able to solve all the questions with the matrix.
Okay.
Can you please help me how to draw the matrix properly so that?
See, just a matrix. See, for example, let's consider this Kajari. Okay, just small example. Let's compare your marks with my marks. Okay. And let's say if I say there is an age from me to you, what does that imply?
You are higher than me.
Okay, my marks are greater than yours, correct?
Yes.
So if I am R and you are C, then ARC will be 1. So if there are, I mean, that means for me there is R is a row, right? The first index refers to row, second refers to column. That's what we are following. So first refers to row, then let's say RC is 1, RD is 1, and RE is 1. Okay, CD. So that means R has scored more marks than CD and E.
Right.
That is what even this statement is saying.
Okay.
Row, right? So in other words, there are 3 students who scored less than R, C, D, and E.
Yeah, I interpreted it a wrong way.
Yeah, so that's what I'm saying. It has nothing to do, to be honest, with pseudocode. It's just the interpretation of the question.
Yeah.
Okay.
I understand the pseudocode, but I didn't understand the meaning of the sentence.
Okay. Now, is it clear now?
Yes. Now it's clear.
Sure. So going back to what Anant was saying. So Anant, have you understood what is this A is all about? A is a matrix of students where there is an age from I to J if I scored more than J. Okay, strictly greater.
Yes, sir.
Okay. So with this matrix, what we are trying to do with that matrix A, we have executed this particular pseudocode. Okay.
Okay.
So n is length of keys of S. That means n is the total number of students in a data set, because keys of S will give us the total count, total number of keys, and that's total number of students in the database. K is 0. It's some integer variable. We'll know why it is used. Then sum score is S of K. K is just the 0. The 0 as in the, let's consider, I mean, we are using S of K. That means S of K is what? The 0th student's marks, right? So with respect to this, 0th student's marks are 50. So that 50 value will be stored in sum scores in this variable called sum score. This will become 50. Then walk is equal to true. Walk is some Boolean variable which is true. Hops is some integer variable which is 0. And while walk. So while walk as in while true, execute this. So till the point variable while is true, we are going to execute this continuously, again and again and again until this becomes false. Okay. So now walk becomes false, and we entered into this loop. For each C in columns of A. Now what is columns of A? Anant?
Yes, sir.
What is columns of A?
Number of students, sir.
Correct. So columns of A is, I mean, yeah, total, it will be number of students, but actually what you are doing is you are iterating over each column of that matrix A. Okay. In that matrix, there are some n number of columns, right? We know it's n by n matrix. So we are iterating on each column at a time. So C is nothing but, let's say, 0th column, first column, second column, third column, and so on, right?
Yes,
so that
sir.
will be value
Yes,
of
sir.
C. C will go from 0 to n minus 1. Okay. And then what we are checking is if A of K of C is equal to 1. Initial value of K is 0, right? Initial value of K is 0. And if we are C 0, 0, because C will again start from 0. So if 0, 0 is equal to 1, of
Yes,
course,
sir.
that's not possible. 0, 0 will not be 1 because, I mean, the diagonal elements will always be 0. So this is not possible. Maybe next possibility, C becomes 1 after this. So 0, 1, A of 0, 1. That means student number 0, the student with roll number 0, scored more marks than student with roll number 1. Then only this will be 1.
Yes, sir.
Okay. So this will be 1 only when K scores more marks than C. That is what we studied. That is what we concluded after studying these lines of code, right? The first entity, the first student scores more than second student, then only it is 1. So considering that, this condition will hold true only if K scores more marks than C. Okay.
Yes, sir.
So if that is the case, we are updating value of K as C. Okay. So if let's say A scores more than B, that means there is a H from A to B, we jump to B. And then from B, we do something else. Okay. Then sum score is also again updated. Walk becomes true. Hop is incremented. You exit the loop. Once again, you start. I mean, exit loop will exit only this for each loop. Okay. The inner loop. But the while loop will continue because our walk is again true.
Yes, sir.
And at that point of time, the value of K is now updated. Value of K is the previous value of C. So what
Yes,
we are
sir.
doing is, let me go back to drawing that whiteboard.
So is that meaning we are taking the smaller value now? Like because the C, the column which we have selected, right?
Not smaller
in that
value.
the value is like I's value is greater than the J value. But now we are storing the J value in I value, like
Correct.
the K, which is. So that means we
Correct.
are taking the smaller value.
Yeah, you can consider smaller value, but that part is not important here. What is happening is, let's assume your original K was A, okay? I mean node A, or let's start with a fresh graph. Okay. How to go to drawing? Draw. Okay, where is the option? Anyone know? Okay. So let's say there is a student. One sec, sorry. Yeah. Okay. So there is a student with roll number 0. And I found that 0th student scored more than student number 1. Okay. So that means there is a age from 0 to 1. So originally, let's say this was our K, right? We already know this was our K. And with respect to this was our C as per the code. So KC is equal to 1. Please do look at the code, right? If that A of KC is equal to 1, then only we are entering into that loop and doing what is happening next, right? So in that case, we are updating the value of K. So now this is not C anymore, or this is not K anymore. What we did is, now this is our K. And now we are trying to find new C. So what can be new C? Let's say there is roll number 2, roll number 3, roll number 4, and so on. So we are trying to find new C. So let's say that new C is, let's say 3. 2 doesn't qualify. Why this is C? Because now student 1 scored more than student 3. Likewise, there is a possibility that this student 3 scored more than student 4. In that case, what will happen is this K will move from here. K will move from there to here, and C will move here. So we are trying to find this particular chain, okay? I scored more than you. You scored more than somebody else. That somebody else scored more than somebody else, and so on. So we are trying to find how far we can go like this. And that is why we are incrementing that variable called hops.
Yes, sir.
Right now, if you see, this is what we got here. When we reached to 4, we found 2 hops in between to reach from 2 to 4. So 0 scored more than 1, 1 scored more than 3, 3 scored more than 4. So that is what is happening in that particular pseudocode.
Yes, sir, I got it.
Okay. So let's go back to that pseudocode. Okay. So that is what, as I was talking about, that is what that hops variable is doing. It is, its value is getting incremented when this condition satisfies. And now with respect to that, this is the question. So Anant, you got this, right?
Yes, sir.
Okay. So can you tell me why it is between 0 to n-1?
Why, sir? Initially, hop is equal to 0, and and at last, at least, sir. मतलब, sir, can I take in Hindi? Sir,
Yeah,
I
okay,
not.
sure. Yeah, fine. Go ahead with Hindi.
सर जब मतलब कि सर यहाँ पे सर एक मिनट सर एक मिनट हाँ सर जब यहाँ पे सर k of c is equal to 1 जब n टाइम तक हो जाएगा सर तो n टाइम होप मतलब कि होप सर n-1 हो जाएगा.
Okay. Let me explain. What is happening is what will be the possibility of value with respect to hops? That's what we are saying, right? We are not asking actual value of hops. It depends on actual data. That is not we are interested in. We are interested in what is the possibility. I mean, what is the range of values for hops, the variable hops, and it ranges from 0 to n-1, both endpoints inclusive. That means 0 less than equal to hops, less than equal to n-1. So hops can be 0, it can be n-1, or any value in between. Now why? For example, we are talking about a student. I mean, the starting point, right? Starting point is our student K, right? That is our starting point. For example, student K is the person with lowest marks in the class. In that case, this condition will never be true. Because if K is the lowest person, lowest marks getter, then KC equal to 1 will never be true. Because the row for that student K will have all zeros. Because K has not scored more than anybody else. So that there won't be any, there you cannot find any such C where value is 1. So, and because of that, ultimately hops will remain as 0. Is this part
Yes,
clear?
sir.
Okay.
Clear, sir.
Now let's consider the other way around. I mean the opposite end of this particular range, which is n-1. What if we traverse? I mean, I explained about this traversing, right? With respect to that whiteboard, we are traversing from 0 to 1, 1 to 3, 3 to 4. What example? For example, coincidentally, we traverse all these students in a decreasing order. Right? Whatever number of students are there, whatever their marks are. What if we traverse that all those students in a decreasing order? Maybe 100, 99, 98. Again, not necessary the 98. 98 after that, maybe next stop directly 80. Doesn't matter. But still in a decreasing order. That means you will get all the students, everybody becomes a hop in between. Because you are going from max to min. Because when you go from in a decreasing order, you are actually going from max to min. And that is when your hops are n-1. Because there are n students and everybody becomes intermediate node. So that's the idea behind this whole question. Is it clear?
Yes, sir. Clear, sir.
Okay. Okay. Yes. Naren, do you have something? I mean, you are on mute, I believe. You said something.
Sorry, sir. I wanted to answer that question, but okay, no issue, sir.
Okay. Okay. Fine. Yes, Kajari. Others, if you have a doubt, please raise your hand so that I will come to know that you have a doubt. Yeah, go ahead.
9.6 activity question.
9.6. Okay.
Question number 3.
Question 3. Okay.
3. How to draw the graph of this data? Can you please show me once?
Okay, sure. So question 3, use the following information for questions 3, 4, 5. Consider the given below. Okay, consider what? Consider the given below sentence. The sequence number. Okay. Fine. So this is given, and what is asked? Choose the correct connected graph between nouns and pronouns based on the concept explained in the lecture. Okay. Okay. And then your doubt is which one of these is correct, no?
Exactly. So I have to draw the graph so that to know that which graph is right, but I'm not able to draw the graph. Which is connect to what? That's why I'm confused.
Okay. So have you watched that particular lecture?
Yes, I did.
Where we have tried to map nouns with pronouns?
Yes, I did.
Okay. So I mean in general with respect to English language, every pronouns refers to some noun, right? That's the standard thing. So considering that, we have discussed that. I mean, that's the point we were discussing in one of the lectures. So look at this particular table. Okay.
Yes.
So what you are saying? Paisam is a sweet Indian dish which is prepared from boiling milk, sugar, and rice. Okay.
Right.
What are the pronouns are there?
There is no pronoun. Paisam is a sweet dish. Which?
Yeah, which is a
Which?
pronoun in this
Which?
case, right?
Yeah,
So when
which?
we say which, it's with respect to that, which is a, I mean, so this pronoun refers to which noun? Forget about everything.
Paisam.
Right? I mean, English wise,
Right.
your 6 refers to 0, right?
Yes.
Okay.
And 0 is connected to 6.
So yeah, 0 is supposed to be connected to 6.
Yes.
Okay. And apart from that, I mean, not just with respect to nouns, right? Any other part of speech also can be connected to some or the other noun, right?
Just like paisam is connected to everything because paisam made by milk, sugar, and rice. So
Correct. So paisam is the noun there, and that has to be connected with various different maybe adjective or a pronoun and so on, right?
yes.
So that is what we are trying to do over here. And after that, there is something else. There are 2 more nouns there. I mean, there are a couple of other nouns, but
Yes.
okay. Now before going towards that thing, first let's try to analyze the given options. Okay. First one, it doesn't make any sense, right?
No, first one doesn't
I mean,
make sense.
I mean that there is no point in. I mean, no need to discuss this.
Yes.
The real confusion, I believe, is between option 2, 3, and okay, the
2, 3, and 3. Only 2 options left.
only 2 and 3. I mean, this is none of the above. It doesn't. It's anyway not the answer. So this is the correct answer as per this given question. Now the point is why this one is incorrect.
Yes.
So before that, what is the difference between these two?
The 4, 5 is not connected in the third one, and 4, 5 is connected to 6 here.
Correct. So only we have to understand the connection which is 4, 6 and 5, 6.
Okay.
Okay. Let's see what is that 4, 6, 4, 6 and 5, 6, right? Okay.
Yes.
What is 4? It's Indian.
Indian dish. Which? Okay. Indian dish is not connected to which.
Correct. Indian and dish both are nouns. And actually, if you look this pronoun, right, the previous noun is actually dish. But when we say which, we are not referring to dish. Or when we say which, we are not referring to Indian. We are actually referring to Python.
Yes.
This is basic English, right? I mean, it's not it's not computational thinking by any means.
No,
But
I was trying to draw graph by this thing, but this will be easy if you go through the answer.
not necessary, right? I mean, even though you don't know the answer, why will you connect this 6 to 4 and 5?
Yes, we will connect only with 0.
Right. So 6 has to be connected only with 0. You're not supposed to connect 6 with 4 and 5. At least that much is clear after looking at this table. Then why, I mean, after looking at, I mean, that's the only difference between these graphs, right? Rest is anyway it's same.
Yes, now it's clear. Now I'm able to understand which one will be, why this one will be right and this one wrong.
Correct. I mean, and that's what even it was explained in this feedback.
And there's a which is pronoun, these things I'm getting confused by that thing.
Okay.
And I'm getting it.
Yeah, okay. Now is it clear?
Yeah, yes, sir. Thank you. It's clear.
Sure. Thanks. Yes, Yashwant.
Sir, I wanted to ask a question from the graded assignment. I don't want the answer, but like, could you give an example similar to that?
Okay. Tell me what your doubt is, then maybe we'll try to figure out something.
Okay, sir.
Question assignment 9?
Yes, sir.
Okay.
Sir, like in the second question,
no? It's 9th of November. Okay, yeah.
In the second question, they were asking like the Cliques question, and so they're asking about the graph, right? Like, how will we draw a graph for a program, basically? Like,
okay. Which of the following statements are true about this graph, right? So this graph, as in which one? The graph which is generated using this pseudocode. This pseudocode will generate some graph, right? Graph, as in the graph, is not necessary that graph will be in a pictorial format. Not necessary. Graph we can store as a form of dictionary of dictionaries. That is what we have done in this entire week, right?
yes, sir.
See, I'll tell you, graph can be stored in many ways. Okay. This is something that's beyond, I mean, this is not something is discussed, but it's maybe important to show you this. So just hang on. This lectures. Okay, listen. Okay, can you see this?
Yes, sir.
Okay, so okay, consider this particular slide. Okay, slide number 5.
Yes, sir.
Let me zoom a little bit. Okay, is it clear enough?
Yes, sir. Clear.
Okay, so Yashwant, now this is a graph. The left top corner, this pictorial is a graph, right? Obviously. But the point is, this same graph can be represented in a tabular structure like this. Yashwant?
Yes, sir. Where the zero means that they don't have edge, right?
Correct, correct. So 0 means they don't have edge, and the numbers represent the value on the edge. So when I say 0, 1 is 3, that means there is an edge from 0 to 1, and the weight of that edge is 3. This is something, as I said, it's something beyond what we have studied so far. So that don't worry about that part. But what I'm trying to teach you is, graph is not just this one. Even this particular table is a graph. This particular, it's a nested dictionary, right?
Yes.
This matrix is a nested dictionary. This is also a graph. So all these are graphs, but the way they are represented is a different thing. This is a pictorial representation. This is a matrix representation, or it's a more accurate term is adjacency matrix. Again, this term will come later point of time if it hasn't come before. It's called adjacency matrix. This is what the pseudocode version of it. It's a dictionary of dictionary. It's a nested dictionary, but still it's a graph. And this is list of ages. So this is another way. Just the mention only the ages. So 01 is 3, 04 is 8, and so on.
Weighted graph.
Yeah, it's a weighted graph. So that's what I said. It's a directed, weighted, all that doesn't matter. Whether it's a weighted graph or a directed graph, undirected, irrespective of all that. The reason I opened this slide is to teach a point that graph can be represented in a multiple ways. One is a pictorial format. Another one is this matrix or a adjacency matrix form. Second is third one is this nested dictionary form, or fourth is a list of ages form. So these are 4 different ways you can represent a graph. Okay. Yashwant? So your point, how a graph or a clique can come from a pseudocode. Yes, it can come from a pseudocode or from some piece of code in this format. It cannot generate this picture, but it can generate a dictionary. And that is what is happening in that particular question. Okay. So the point is, will be a confusion. I totally understand the point from where you are asking this doubt. So what is happening is, see, I will not explain you the pseudocode because I cannot. But if you observe line number 7, no, sorry, not 7, line number 8. We are creating B is equal to create matrix. So B is what? B is your graph, right? Why we say create matrix? It creates that adjacency matrix. Initially, it is with all 0, 0, as explained in the lecture as per this line. But afterwards, there is some lot of computation is happening. And because of this computation, B will have some values in it, and B will have some meaningful information stored in it. So B is your graph. So with respect to that B graph, we are asking this particular question.
So I got disconnected for like 1 minute or so. You were discussing this question only.
Yeah, I mean, I of course I did not discuss the answer or anything, but
Yes, not the answer, but
yeah. Okay. Anyway, I mean, you go back and watch on YouTube because I have given a lot of explanation on top of it. But just
okay, sir.
just a quick summary in 2 sentences. First, graph can be represented in many forms, not just pictorial form. Okay. First,
Okay, sir.
and
Yes.
second, as per this pseudocode, your B is a graph.
Yeah, the matrix P, right?
Yeah, matrix, right? It's a matrix is what? It's ultimately it's a graph is represented in a matrix form in this case.
Yes, sir.
And
Yes.
internally, if this create matrix creates what? It creates a nested dictionary. So that
Yes,
is
sir.
what the questions are based on this particular variable B. Whenever we say which of the following statements are true about this graph, that means we are talking about that variable B.
So
Now
can
you
we
have to-
consider 2-dimensional arrays as matrix as well?
2-dimensional arrays as matrix, huh? Yeah, you can, but that is not how we have designed matrix in computational thinking, right? With respect to graphs, we have designed it as dictionary of dictionaries.
Yes, yes, sir.
Because we have not studied arrays yet. Do you remember
Yes.
any place where you studied arrays?
No, sir.
No, right? So we have not studied arrays. So everything is either list or dictionary or some combination of 2. So matrix is a nested dictionary, as in dictionary of dictionaries. All right.
Yes, sir.
Yeah. I mean, it's a graded assignment. I cannot tell you more, more than this, but try to solve maybe some practice questions of week 9 first. That will clear many of your doubts. When those answers are available, so try to solve those practice questions first. All right, Yashwant?
Yes, sir. Yes. Okay.
Okay, sure. Thanks. Yeah, Tarika.
Sir, one more query. Just here on the grade assignment, there are some computational question, like we have to compute the numbers. This kind of question will come in the exam also, like 4 to 11 is given there
Okay, let me see
in
what
GA.
is. Yeah, first let me see what is 4 to 11.
Okay.
Okay,
Yes.
4 to 11 is some numbers are given, and yeah, it's possible. It's possible. Some of actually it's not a computation. I don't know whether you have read the question correctly or
Sir,
not.
I have a question related to this only.
Yeah, okay. So actually, this is not a computation. You don't have to do any computation.
Yes, sir.
See,
Sir, I don't want to ask about the code.
Yeah.
Just this screen, like the options.
Yeah.
Sir, I wanted to ask, like, you will help, if you can, you just help me to understand, like, collaborators. As per my understanding, collaborators are the authors who write, like, 2 authors writing the same book, like together they are writing the book.
Correct.
They are collaborators, right?
Yes, correct.
And the publishers are not the writers. They are who publish the book. Like, if me and XYZ is writing a book together, then I will give my book to somebody else, some publication
Yes,
company.
that is correct. But here, publication company is not something. I mean, it's not even in the picture.
Yeah, that's why I'm asking. It's not in the picture.
Yeah.
Then why in the options the publication? I mean, it is there. Like,
Okay. For example, I will explain. I can explain you the option. The meaning
yeah,
of
just
option.
options.
Okay.
Yes, just
So
options.
the second option, an author with the maximum number of publications. Right. So this publications has a maximum number of books. An author with the maximum number of books. That is how you can read it.
Okay.
See, I'll tell you why we use word publications. Publications is more generic word, because when you say books, it is precise to books. But when we call publications, it can be a research paper, it can be some article somewhere, it can be a book, it can be some chapter of a book, it can be anything. Right? So publications is more generic term, book is more precise term. So
okay, sir.
If you are more comfortable with books, replace all publications with books. Doesn't matter.
Okay, sir. Then how about option 5?
Option 5, maximum number of books published by any pair of authors. So maximum number of books which are released, in this case published as in they are released by same pair of author. So still we are
Written by
talking about
the books written by same pair, we can say, right?
correct, exactly. That is what that word is. So that's what I think. The publication with respect to book, what you talk about, right? Some organization who makes it happen, right? The person writes is different, and there is organization who takes care of printing and advertising and marketing and distribution and so on. That is publication, right? Standard in real life. That is not we are talking about over here. We are talking about something which got released. That's the publication. With respect to that, I mean, the word publication is used in that reference. Okay.
But in simply, the books written by two authors.
A pair of authors.
Pair of authors.
Yeah, the maximum number, max. Yeah, I mean that's what the maximum odd number is. But yeah, that's option 5. Correct.
And likewise, the last option, maximum number of books published by any author,
Any
means
author.
written by.
Written by any author. Correct.
Thank you, sir. It actually helps a lot.
Exactly. The options are really confusing.
Because that publish word, I was literally taking it as a publishing company.
Okay. No. That's why I said it has nothing to do with that. It's purely based on authors and the books they have written. That's all. Okay. And as somebody else, I think, I don't remember. Somebody was talking about computation. There is no calculation involved. Just 8 options for every question. So this fourth question has 8 options. Fifth one has 8 options, and so on. That's how actually you should read.
I got it.
Yeah. Okay.
Sir, one more thing I wanted to say to Yashwant, if you allow.
Yes. Yeah. Please go ahead.
Yashwant, if you were there in yesterday's class, in Bhaskar sir's class, were you there?
No, I missed the yesterday's class. I think
then you check the recording. You just go through the YouTube. In that, he has shown like how to make a graph. The very first question is related to, I mean, it's very much same like the this graded assignment. That will help you.
Thank you very much.
Yeah.
Okay, great. Yesterday only there was a session, huh?
Solve with us.
Oh, solve with us. But still back-to-back sessions, huh?
Yeah.
Oh.
Because tomorrow is the last day.
Oh, okay. Okay, fine. So yeah. All right. Any other doubts?
No, sir, not from my side. Thank you.
Okay, sure. Thanks.
So one thing about the list and dictionary implementations that we studied.
Yeah.
In lists also we can randomly assess by index or not, or just we have to we want to assess L of when we are implementing matrices as a list of lists. Can we not are we not directly assessing an element when we are saying L1 of L square bracket 1 square bracket 2?
No, that's not allowed with lists.
Okay, we just have to iterate over that.
We have to iterate over that.
Okay, but because
in
the board in the both of the list when we are implementing matrices as a list of lists and as a dictionary of dictionaries. The thing is that when we are assessing or updating or computing anything based on the value, we are just using the statement like list with an index and then further index. And similarly with the dictionary also, dictionary, index and the sub-index.
Okay, so Ankit, right? Yeah, Ankit, when we are saying that first index and second index, right, we are not actually talking about list. Even though it is a square bracket, it's not a list. It is still a dictionary only which we are updating upon.
So that thing I know, but it's just about the index thing that I'm a bit.
Okay, I'll tell you. I mean, before going into that explanation and why it is so, do you have any computer science background?
No, sir.
No, not at all, right?
No, sir.
Okay, then it is a bit tricky, but okay. See, what I mean, from where you got this index part? Because index word is not actually with respect to, it's not there at all. I mean, that's why I was curious. I mean, I thought you have some background, and that's why you're using this word index. So where you heard this index?
Sir, it's in Python class.
Yeah, that's why that's why I was asking that you are studying two things which are exactly opposite of each other. That's why this confusion. See, that is why I was explaining to Ganesh or somebody. I think Ganesh only. That see, in Python, when we talk about lists, right? Python lists are different. They are not, I mean, they call it a list, and that is how Python treats it. But Python lists are they are not actually lists. They are something else, to be honest. Okay. The way they are implemented internally, they are not lists. They are actually arrays.
Okay, sir.
Okay. And arrays allows us this index access, or the concept of index comes with respect to arrays.
Okay.
Okay.
So, sir, if we are talking about the rest of the programming languages, then we cannot directly call a particular value in a list. Like
in a list. No, exactly. Because see, list is actually, it's a short term use for the actual data structure. I mean, if you Google it, you will find some data structure called a linked list.
Okay, sir.
Okay. I'll just where is this?
So I'd open it's like squares and pointing to another.
So I'm just typed it in the chat window. It's called linked list. Okay. So this is one special type of data structure, like dictionary or like a list and so on. I mean, list is what this link list is. Okay. And it doesn't allow that indexing part, because the way it is designed is like this manner. Okay. I mean, this is something which is not there in CT. We avoided this because it might have created a lot of confusion. So we thought, oh, let's not go into this depth at first level. Later on, maybe we'll do this, and it's there actually. But as an introductory course, we should not go into this depth. That's why we avoided it. So, but as you have asked, I will try to explain. Okay. It's more like first node is zeroth node is connected to the first node.
Okay, sir.
Okay. First node is connected to second node. And because of that, zeroth node doesn't know about second node.
Okay, sir. It's just like something like when we are writing a pseudocode to treat our matrix implementation of list of lists. When we are on that segment, then only we can assess that certain value. Otherwise, we cannot.
Correct. So I mean, yeah, what you're saying is correct. So actually, linked lists are generally drawn something like this. So this is my first node. This is my second node. And if you see, each node has two subcomponents in it, right? So how it works is, so let's say I have some value A stored here. I have some maybe B here, maybe let's say 10 over here. It may look like 16, but doesn't matter. 10, 20, whatever, some value is there. And then this second part, right? Second part is actually address. So first node, the zeroth node, right? This is my zeroth node. This is my first node. Let's call it. Actually, this concept doesn't exist. Zeroth, first or second. This doesn't exist with list. So what happens is this one has address of next one. B has access of next one. This 10 or 16, whatever is, it has access.
Python is also save that memory location.
Not memory location. Yeah, I mean, yeah, memory location is correct. So see, ultimately you have required memory to store anything. That's obvious, right?
But this thing happens with C and C++. That's why I'm asking. Python is also doing the same thing.
No, actually, the thing is in Python, lists are not there. We call it list in Python, but actually it's an internally implementation. It's array only. That is why in Python, even though it's a list, it allows us that, random with that index access.
Index access, yes.
Because the confusion is the word of, the use of word list. In Python, everybody calls it a list. Even the Python developers call it a list. but actual internal implementation is like an array. And that is why we can do that. But with a standard concept of linked list, this is the structure. And that is why you cannot say directly, I want to access this node. You cannot, because you cannot directly go here. In order to go here, you have to first go here,
Traverse.
then pick the address of next one, then pick the address of next one, then only you reach here. That is why that for each loop is the only way to reach here. Or is that other one, right? First of this, last of this, or init and rest, all that mechanism. And this is the limitation of list or linked list. Python list is an exceptional thing, and that's why there is a lot of confusion. I understand, but that's something I can't avoid because that is how Python is developed and that is how Python is used. But internally, Python's lists are implemented using arrays. And this is something you will study in week 2 or week 3 of PDSA, where Madhavan sir will come again and he will talk about this once again. Okay. So this is there, but this is too early or this is bit too advanced to discuss at this point of time. So it will come at later stage. Even I have some small lecture on this in Python, but not again to this level of data structure perspective. My lecture is with respect to Python perspective, but with respect to data structure perspective, as I said in PDSA week 2, either week 2 or week 3, I'm forgetting it, but it's definitely there. That how lists and also how dictionaries, both lists and dictionaries of Python are implemented internally. So this complete package is there in that particular week. Okay. So he even demonstrates that with various examples and even proves that yes, it is actually implemented using arrays. It's not actually a list, even though we call it a list in Python. So it's with explanation and proof and demonstration, it's all there. So till that point, just believe on me, and then later on you can see the proof of it. Okay. And that's why this confusion arises with many people at their initial days. That list it allows us the index wise access. Then why we are saying it's not there? It is actually not there. As I said, Python is the only exceptional place where it is there because it's not actually a list.
So similarly, we can see that index is just like a convenience way to just see that how we reach there.
Correct. It is, it is a convenient way, true, but it's not accurate.
Got it, sir. Thanks.
Yeah, sure. Thanks. Okay. Yes, Naren.
Sir, activity question 9.1, question number 6.
Okay.
I'm not able to understand the feedback, sir.
Okay, sure. 9.1, right? Question 6.
Yes, sir.
Okay, question 6. So yeah, feedback is there. Let's come to feedback later. Okay, what is the question?
How many maximum number of study cycles can be found between two students for mentoring or be mentored? That is actually be mentored in 3 subjects.
Or by mentored. Okay, fine. Anything is fine. By mentored in 3 subjects.
By mentored means what, sir? Okay, for mentoring or by mentoring? Okay, mentored.
By mentored.
By,
either you mentor somebody or you get mentored by somebody.
Mentored by. Okay, no problem. Yeah. So
and the answer is
3
6
subjects in that. Okay, 2 students are there. So if one student is mentoring another student, the other student cannot mentor the first student.
Correct.
So already one subject is gone there. So another 2 subjects, that second person who is mentoring the first person will be mentored by the second person for the other 2. So how 6 is coming? Answer.
So can I explain this point?
Yeah, sure. Go ahead.
It's like the number of choices that we have, like for a student A and student B, when we have, and if we directly connect them, then we have 3 options of mentoring. But on the following subject, as the same subject cannot be taught between the both the students, like A cannot teach B in math and B cannot teach the same subject maths to A. That's why the number of choices on the second step rises to 2 at the second step. So the multiplication is 3 into 2. For the last cycle, we can consider that we are only left with one option. It does not matter that what subject who teaches who. So the answer is 6.
No.
Okay, so
Separate.
Naren, it's like a multiple combinations you can find, right? Within those 3 subjects.
Okay. Multiple combinations. How many maximum number of study cycles? Okay.
Yeah,
Study
so
cycle number 1 can be
it's actually a
do.
statistical problem that
I
how
got
many
it. So study
combinations are possible.
Yeah. A can mentor in 3 subjects. That is, then 3 cycles are there. Similarly, B can mentor 3 subjects to A. So there are 3 cycles.
Not 3, but then actually it reduces by 1, right? Because the subject taken by A, B cannot repeat that. So B again has only 2 options left. So that's how it becomes 3 into 2.
No, what I meant is A can mentor B for all the 3 subjects.
Correct.
So there are 3 cycles in that.
In that manner, right?
Similarly, B can mentor A all the 3.
Correct.
So, I mean, am I right, sir? I don't know. I'm
Yeah. I mean, you're what you are saying is correct. So all these various possibilities are there, right?
Okay. So then 6
that,
possibilities are there. Maximum. That is the maximum number.
Correct.
Okay. And let 2 students A and B arrow from A to B. B mentors complete cycle. B mentor. No, cycle. This first feedback number 1. Why it is like 2 students A mentors A arrow be formed between A and B. First one I understood. Let A mentor in physics. Then to complete the cycle, why we have to complete? Sir, already this completed only, no? Cycle, okay. One A has to teach something and B has to teach something. So that is called a cycle.
Yes. See, what is the cycle? You go from one point to other point and you come back to original point. Then only it becomes a cycle. Okay. I traveled from, let's say, from Pune to Chennai. That's not a cycle. That's just a path. When I come back from Chennai to Pune, it becomes a cycle.
So that is one cycle. First, for one subject, either one of the subject, the other person will teach. So one cycle is over. So 3 subjects are there. So 3 into 2, 6 cycles will be formed.
Right.
Okay, sir. I think I got it.
Yeah, I mean, now later on with this information, read this question once again. Okay,
yeah,
you'll get more
sure.
clarity. Okay.
Sure. Thank you, sir.
Yeah, thanks. Okay. Yes. Anybody else? We have still half an hour left.
So it's a general doubt. Like many of the questions, especially in the quizzes and especially in the week 8 assignment, I had many errors in understanding the pseudocode. But later, means what's the way that we can avoid these errors? Means at the first time,
errors are there in the question, or you made errors
from understanding, like
okay, from understanding perspective. Okay. Okay.
In quizzes,
Can you tell me some specific type of errors which you made?
Just let me open. Like, so it's just like when we are studying a pseudocode, sometimes we skip some of the few points which are to be noted when answering some of the questions.
Okay.
Like, just let me just. Can I share my screen?
I believe, I don't know whether it's allowed or not. I don't have that.
No, it's not visible on this thing.
Okay, hold on. Let me see whether I can grant you that permission somehow. Okay, what you are going to present? What you want to present? Maybe I can present.
It was a week 8 graded assignment.
Okay, then that's easy, right? I can present instead of you. Just tell me the question number you want me to present.
Like, so in question number 6, I missed the point. It was a multiple type of questions, and
question 8, right? Yeah, this one. Okay. This is not multi-choice question.
So it's multi question 8.
Question eight.
Just a sec. Sorry, question 6.
Okay.
Just scroll down.
Okay, yeah, question 6.
Yeah,
Yeah,
it's like I selected key of the dictionary that is an integer, but I altogether miss the point on the first side that all the values of the dictionary are non-zero.
Okay.
So this type of errors, especially in the multiple
Select questions.
occur sometimes.
Okay. So, but okay. After reading this option, I mean, after seeing this being a correct answer, you understood, right? Why this option is also correct?
Yes, sir.
Okay. Okay. So you did not had any doubts that, oh, why this is the correct answer. That confusion was not there. After reading this, okay, you understood that, yeah,
Yes.
I missed it. That part you immediately got that, right?
Yes, sir.
Okay. So in that case, I believe you understood the pseudocode. The problem is not with pseudocode. The problem is maybe you did not pay enough attention towards all options.
Okay.
I mean, that's how it appears. I am not saying that's the case, but the way you said or whatever happened, it appears like you have understood everything, but while reading option, maybe in a hurry or something, I don't know, you overlooked at other options after finding the first correct answer.
That might be the case. I don't know.
Because see, if you haven't understood why this is correct, then
Yeah.
some problem is there with your understanding of pseudocode, right? But you
Yeah.
understood, okay, yeah, this is a correct answer. If you have understood this and still you have not selected this, that means you overlooked at it. Maybe okay, this is the correct answer. Quickly, okay, no, next question. That might mean a hurry or something. I don't know
Yeah,
what.
but it's like I'm taking assignments as a challenge to do maximum number of questions in the shortest amount of time. So
Yeah, that is how it should be. But maybe time is something you can reduce the importance of time little bit with graded assignment. Not too much, maybe a little bit reduce the. It's okay to take maybe slightly more time, but maybe do it accurately.
So the thing was that in the quiz, like in few questions, I was having a bit of pressure in the quiz one that we are having a little bit of less time there. So I was just I should approach that challenge in a ungraded because let's see how well I do there.
Yeah, I understand. I understand the reason behind this strategy, but maybe that was the reason. You're taking that taking some challenge upon you to finish this within some given time limit, right? And in that, I believe you overlooked at the option. I believe that's the reason here.
Yeah, that seems to be the case for me also.
Yeah.
Okay.
Sir?
Yeah. Yes.
Sir, question graded assignment 8, question number 3, sir. That cities.
Okay.
Still, I am not able to understand.
Graded assignment 8, question number what you mentioned? Question
3,
number
3.
3. Okay. Yeah, somebody else also mentioned that he's not able to understand. Who's that? Naran
Yes, sir.
and
Anant Kumar.
right? Yeah, okay, yes.
Anant.
Yeah, Anant, got it. Okay, question number 3. What is the following pseudocodes? Okay, so we are asking about value of B at the end, right? And the answer is 10. I don't know what is happening, but yeah, its answer is 10 after this. Okay. So what was your answer, Anant and Naren?
Sir, I was not able to get at all the questions, sir. I did the entire score sheet. He wrote Salem, Chennai, and whatever the highest mark was there, it will be going to the, it will be updated. That much I did for all the cities and all the 3 subjects.
Okay.
So D is update dictionary by field, mathematics. So table in line 10, table 2 has more rows, read the row. If eligible, I mean, whichever is higher, So that higher mark than the previous one, it will be updated city-wise.
Correct.
So city-wise, the highest mark in each subject is coming. So that is up to that only I am able to understand that. So how this C is calculated because D sub that I am not able to still understand even after going through the answer.
Okay.
What the pseudocode is making up to a certain level, I did, sir. Like what I did was what I can see is each city, the topper in the each city of each subject. That much I have calculated is that.
Correct. So your dictionary is D, right? That is
Yeah.
what you're computing, right? You started with D and you in entire pseudocode we are building up this variable D, this dictionary D.
Yes,
correct?
Correct.
Right. So what is actually the final value of dictionary? I mean, not actual values, but what is the structure of dictionary D? At top level, there are three keys: mathematics, physics, and chemistry. Correct?
Yes, correct.
And under mathematics,
cities.
Sorry.
And the mathematics within that dictionary will contain the cities with higher marks.
Yes, correct. Sorry, I opened something. Okay, yeah. That's actually not required for this question. Okay. Okay. So what you are saying is correct. Under mathematics, for each city, maximum marks of mathematics will be stored. Like Chennai, some number, Bengaluru, some number, Vellore, some number, and so on. Right?
Yes, correct.
Similarly, there for physics. Similarly for chemistry.
Yeah, all the three dictionary. I mean, all the three subjects in one dictionary. It's a nested dictionary, like something like that.
Yes, it is a nested dictionary. It's a dictionary of dictionaries where outer level keys are subject names and inner level keys are city names. And then what we are doing, if for this particular subject X, right?
Which line, sir?
No, I'm finally this is where C is getting computed, right? The question is about B or C.
30.
What will be the value of B at the end of execution? That's the question, right?
10 to 13, 14. Line number 10 to 14.
10 to 14. Yeah. So this is where we are checking B, right?
Yes, sir.
So B is getting incremented here. We started B with 0. When it will get incremented with when eligible returns 1. I mean greater than 1.
Yes.
So eligible returns greater than 1. When it will return greater than 1?
For each subject in subject list, if D subject and D city tone equal to X subject.
So you have given some subject as a parameter. So value of X can be either mathematics, physics, or chemistry. It cannot be anything different than that value of X, correct?
Yes, sir.
Oh, sorry, X is a student. My bad. X
subject.
is something we are iterating on a table. We are passing that X as a parameter, right? And what we are checking, whether that X dot subject. So subject is a sub list. I mean, we are checking X dot maths, X dot physics, X dot chemistry, all three.
Okay.
And if D of subject of that particular town.
The dictionary of the subject, that is, if I take max, the D of max of that particular city should be equal to the particular person who is the X. It should be equal to the X of the subject.
Correct.
X is the name. I mean, it's a key for the person.
Correct.
So, if, for example, E road, it is coming 72 for max. So, what it will make? If a person who has scored 72, the highest is E road is 72. So, what will happen to C?
Okay. So, what is happening? Your subject. So, X is entire row of the table. Correct.
X is
for entire row of the table, right? Entire card. You can say that entire scores card. That is X.
Okay.
So, from that X, you have picked the some city. And subject is anyway, it's maths, physics, and chemistry. You are checking for all three. And for that particular student city, we are checking whether that subject is equal or not. Because what is X dot subject? It will give you the marks. And these are also marks coming from dictionary.
Okay, sir. So C, when it get incremented?
Okay. So when it will get incremented is when that particular student gets highest marks in that particular, is the highest marks getter for that subject in that city.
Okay, correct.
That is when C gets incremented. And if that student can be a topper for his or her city in multiple subjects, possible?
Possible.
So C value can be 0, 1, 2, or 3.
Okay. C value will be 0. No, obviously, one of the student will have a topper in that. So C will always be more than, it will be up to 3.
Correct. No,
It will be
not up.
3.
Yes, but definitely C will be, there will be at least one topper, right?
Yeah, one topper for one subject. We are checking for all the subjects, no, in this.
Yes, for all the
of
subjects.
3 subjects, one topper will be there. So
Correct.
C will always be equal to 3.
It will be always be equal to 3.
Okay.
At some point it will increment and will become to 3. It will go to 3. Correct?
Yes, sir. At the end of the procedure, it will become 3.
Right. And
Let's see.
Correct. So what is happening is this is for each city, right?
Each city.
So for
okay.
So for each city, right? Because second parameter is important, which is city.
So each city also minimum 1% will be a topper.
Correct.
In one subject.
Correct. So similarly for each subject, there will be some or the other topper.
Yeah. So 3, C will have a value of 3 only, no, sir?
Yeah.
Can it take a value lesser than that?
Yeah, it's possible, right? Because
how, sir, anyone in a city, at least one topper will be there for each and every subject.
But X is one person, right? X is not all students. X is just one student. For that particular student, we are checking for 3 subjects.
Okay, sir. It can be less than the minimum value you can take is 1 and maximum value it can take is 3. Okay.
Okay. So yeah, what is happening is at some point, this current student X may not be the topper, but as we are iterating on all students, definitely at some point of time, value of X will be the value of topper for that city.
Yeah, up to that time, procedure eligible, I understood, and I think I understood that time also, sir.
Correct.
So C will have some value, anything between 1 and 3, 1, 2, or 3.
Correct. But
that much we have finished. Yes, sir. Next.
Correct. But as you have mentioned, as we are iterating on entire student list, definitely we'll get toppers also here and there.
Yes.
May not be. So what is happening is at some point of time, we'll get that C is greater than 1 when the actual topper comes.
Yeah.
And that is when B will be incremented.
Oh.
And this will happen by default for every city.
Okay.
Correct.
The highest mark in any subject per city.
Per city, correct.
Okay.
They will be, see that student, the way the dictionary is computed, the information is always there, no?
Yes, sir.
So what is happening is there are how many total cities are there? Unique cities are there?
Salem, Chennai, Madurai, Ambur, Vellore, Bangalore,
10 are there.
Nagarkoil.
10 are there.
Yeah, 10 are there.
So what is the answer of the question?
So number of cities, it will be equal to number of cities.
Exactly, because when we iterate on entire data set, some topper will come, no. So value of X will be equal to topper's value. And when that is the case, this
can be any
will
subject.
return.
It can be any subject.
Yeah.
Topper in one of the subjects.
That is why we are doing this particular procedure for all 3 subjects.
Individually. Okay.
You got the point?
Yeah, I actually 10 I can correlate with number of cities.
Yeah.
But where it is coming, that is coming in 10 to 13, 14 lines we are eligible. Eligible is the one we have to see. Eligible. C has to be more than, okay. In eligible, procedure eligible, one of the city only will come, no, sir. Each time I do procedure eligible, the output will be only one.
Yeah, only one city, right? Because city field we are picking up from that student's row.
Okay.
So that student is, let's say, from Chennai, then definitely that student is from Chennai, irrespective of subjects, right?
Okay.
That this information will not change.
Okay. Procedure eligible, we have to give the name of the city as
Correct.
X.
Because when we give X, along with X, that student's
There
city
will be
also
some
comes, right?
city.
Correct, some city.
Okay. Okay. Anyhow, sir, as I told last, anyway, with this background, I will once again go through it, sir.
Yeah, better. I mean, maybe, and one more thing, don't do it now. Maybe do it
Okay.
tomorrow morning with fresh mind or something. Okay.
Sure,
Yeah,
sir.
that will be better.
Okay. Okay.
Sure.
Thank you.
Yeah.
Thank you.
Thanks, Naren. Okay. Yeah. Anybody else? Still have 10 minutes left. So, anyone, any doubts?
But in this question, we are supposed to go through entire data, no, sir?
Not actually, not required. No.
No,
I mean,
otherwise,
if
how
you
will I
can,
know 10 cities are there, sir?
yeah, I mean, you don't have to process it for every value. You just have to see how many unique cities are there, right?
So in case, that is, if you would have understood that line number 10 to 14, then you would have done that.
Yes, correct. Then you don't have to waste your time in actually looking at the numbers and who's max from city and so on. That was actually not required. Just wanted to find how many unique cities are there.
Anyway, I have done that and wasted a lot of time on that.
Yeah, exactly. So actually what happens in exams, many times student creep that we ask some lengthy questions. Actually, it wasn't a lengthy question. It was a logical question.
Okay.
If you have understood it, how much time it takes to find unique cities? It takes less than a minute, right? To find how many
All the
number of
30,
unique cities.
29 cards, you have to just push out.
Correct. And in fact, I mean, by now you should even know this. There are 10 unique cities, right?
Maybe, sir.
And we have seen that the data set so many number of times in many questions that by now we should know, okay, that there are 10 cities. So that's what it is. Okay. Okay. Anybody else?
I think from 32, we have come to 13.
Yeah. Yeah,
Okay.
that's the standard pattern. But later on, if you go back later, I mean, maybe tomorrow morning or tomorrow evening, you will see the YouTube count that will be higher.
Yes, sir. Okay, sir. Thank you very much. I think I'll also leave. Another subject is starting next, max
Okay.
statistics.
Sure.
Thank you, sir. Bye.
Sure. Thanks, Narendra. Okay, so if no questions, shall we close?
Yes, sir.
Okay. All right. Bye everyone. Thanks for joining.
Is the meeting over? Yeah, I think so. Is the meeting over?